Okay, so now simplifying rational expressions. So we have something, a rational expression with fractions. And to simplify this, it means you need a factor, and then you cancel out common factors. So that's one of the reasons why factoring is so important, because it is needed for things that follow. And then I also have linked here 3 additional links about factoring. So if you need some additional help with factoring, check out those links as well. And before we even get to any examples, now I need to connect the domain to the simplifying rational expressions thing. When we cancel out common factors, we're basically dividing them out from the top and the bottom. And because we're dividing them, you can't divide by 0. And so we have to make sure that whatever we divide out, that's not 0. So you have to specify that whatever you just removed, the x value, what x values make that 0 are not allowed, because then you're dividing by 0 and you can't do that. So that's the general rule. It basically takes the original expression you're given and the domain there, and then if you cancel something out and your domain is different in the simplified version, you have to specify the domain of whatever was missing. So this will make much more sense when you see this worked out. Okay, so it says, so I've got 2 examples here to start. Write the rational expression in simplest form. So we saw things with exponents, we call them exponential expressions, but it's also technically a rational expression because we have a variable in the denominator. And so we can simplify this like we would simplify any other exponential expression. But what's different here is when we're considering it as a rational function, we have to consider what values make the denominator 0. So here I have 60y to the 5th. So I can't plug in 0 for y, because then I have 60 times 0 and I get 0 in the denominator. So y cannot equal 0. So we have to keep that in mind when we're simplifying. And if we end up having no y's left or something like that in the end, we may have to write that. So I've got my rational expression. And the first thing that I do is reduce the fractions. I've got 18 and 60. And I may not reduce it the smartest way. I just reduce it by the first numbers that I see that I know go into it. So I know that 6 goes into 18 and 6 goes into 60. So I'm going to just make a little note to myself, and I'm going to divide each of those by 6. So 18 divided by 6 is 3. 60 divided by 6 is 10. So I know I have 3 over 10. Now for the variables, when we have an exponential expression, you subtract the exponents 2 minus 5 is top minus bottom. So there's going to be y to the 2 minus 5, which is negative 3. And then if I have a negative exponent, I need to get rid of that negative exponent by taking the reciprocal. And so that will actually put it in the denominator. And we end up with 3 over 10y to the 3rd. So that's the simplest form. That's basically just a review of p.2. And we don't need to restate the domain because we are still not allowed to have 0 in the denominator here. We didn't remove, it's still the same. So here we got y not equal to 0. So it hasn't changed from the beginning. So we don't have to mention the domain in this case. Now I'm going to look at the second example, and this is what we consider more traditional rational expression, where you actually have things added and subtracted. You basically have polynomials on the top and the bottom. And to do that, we need a factor. So first off, I'm going to rearrange my top, the numerator, so that I have negative 4x plus 12. And I do that just because when we work with rational expressions, you want to always be decreasing in powers, or so you have your variables first and then your constants are last. So I have negative 4x plus 12 over x minus 3. And now I want to factor. So this is why being able to factor quickly is helpful, because otherwise you have a lot of steps that you're writing down. So the numerator, 4 and 12, I can factor out of 4. Because I have a negative in the front, I'm going to factor out a negative 4. So I'm going to then divide out a negative 4 from negative 4x plus 12. So that will leave me x minus 3. Because 12 divided by negative 4 is a negative 3. In the denominator here, I still have x minus 3. And there's nothing to factor out because the only thing in common between the x and the 3 is just 1. Now we want to cancel out common factors. So I'm going to highlight here that the x minus 3 is on the top and the bottom, and we can basically cancel those out. So this is very similar to what we did with factoring. The exponents in each of those would be 1. 1 minus 1 is 0. They're gone. And so our answer here results in negative 4 because everything else basically canceled out. Now, here's the thing that we have to consider, and that's the domain. So in our original problem, x minus 3 cannot be 0, which means that x can't be 3 because 3 minus 3 is 0. That has to carry down to our answer because we divided everything by an x minus 3. We basically removed it. We don't have any variables left. So this is the part that the book is very particular about, that whatever we canceled out, the x minus 3, we have to make sure we specify that this simplifies to negative 4 for everything except x equals 3. Because that was not allowed in our original problem, and so it's still not allowed in the simplified part, even though we don't have any x's at all. Okay, so I've got a couple more examples here. I may actually have to split these up into 2 separate screens because I may run out of room. Okay, so we're doing the same thing. We're simplifying. So maybe let me start off with the domain before I start simplifying. So maybe that will help. So on the left, we have x squared minus 5 over 5 minus x. So our denominator of the fraction, we cannot have that equal to 0 because then we're dividing by 0. So that's what gives me 5 minus x is not equal to 0. And let me make a better not equal sign. And then I ask myself, what number, if I plugged into x, does make that 0, because that's the number I'm not allowed to plug in for x. Another way to look at it is that you're actually solving that equation for x, which means you're trying to get x by itself. So in this case, the solving process, which we haven't technically really learned, but you'd be adding x to both sides of the equation so that the x's cancel out on the left. And then that would be left with 5 is not equal to x. So if I plug in 5 for x in the denominator, I would get 5 minus 5, which is 0. That would mean I'm dividing by 0, which I can't do. So that means I can plug in any number for x except 5, because then that causes a problem. So that's why in our domain, we're allowed to have any number except for 5, and that's where the x not equal 5 comes from. Does that make sense? Okay, good. Let's start by step by step. So now we don't have to care about that part until we get to the very end. So we just do that off to the side, and then that comes back in again after we've simplified. So I'm going to do what I did in the previous example, where in our denominator, I want to put that x first. So I'm going to start by rewriting it. So I have x squared minus 25, And then I have to make sure my signs match up, so that becomes a negative x plus 5. Once I've rewritten that, now I need to factor. Now I'm not going to show all of the factoring steps since I did a whole video on that. But the first one, the x squared minus 25, that is a difference of 2 squares when it factors. That's one of our special ones. And that will factor to x plus 5, x minus 5. And the order there doesn't matter that you write them. The denominator here, it doesn't factor like a binomial because we don't have an x squared, so I just look at a greatest common factor. And I don't have numbers in common between an x and a 5, or like I can't take out an x, but because I have a negative in front of my x, I do want to factor out a negative 1. So I'm going to write down my greatest common factor, which is negative 1, and then I'm going to divide each part by negative 1, which basically changes the signs so that I have negative 1 times x minus 5. And now I look to see what cancels out, what matches on the top and the bottom. If it matches, then it disappears. And then we're left with whatever's left over. That negative 1 we usually just put in front because dividing by a negative is the same as multiplying by a negative. If there was a different number there, then we would have a fraction, but 1, it doesn't really matter. And then I'm left with x plus 5 because everything else canceled out. Now I have to go back because I canceled out the denominator and that was part of the domain. I have to stick that back in, the fact that x cannot equal 5. Because that was what happened, that relates to what we canceled out. So this x not equal 5, that comes from the x minus 5, which that x minus 5 part basically came from the negative x plus 5 part. And then all goes back to our domain. Because if I have x minus 5, 5 minus 5 is 0. We can't have that. And so if we put in 5 for x, we're dividing by 0. And so I have to specify that I can't plug 5 in because the original function didn't allow that number. Even though I can put 5 into our answer here, if I plug in 5, I get 5 plus 5, which is 10. I get negative 10. That's okay, but it all depends on what was not allowed in the original that we started with. And so because we originally started with something that does not allow 5, we are still not allowed to have 5 in the end, even if it does give us a number. Okay, I'm going to switch to a different color for the second example just so that we don't get confused with these. Okay. The second one that I have here is more common. This is like what you're going to see a lot, especially on the practice. And so we have a trinomial on the top and the bottom. I don't have to rewrite anything because it goes from x squared to x to something without x. So the order from highest to lowest as far as exponents goes is fine. So the first thing you want to do is factor, and you need to factor the top and the bottom. And so I basically, both of these, because there's no number in front of the x squared, I would just be doing guessing and checking here for factoring. If you are someone who is not yet at that point where you can factor quickly, what I recommend you do before is to, let's see, I'll just kind of demonstrate how I would organize this first. So I would just have something labeled top, and then bottom. And then I would do the factoring for each of those separately, go through those, and then stick them together. So that would be especially helpful if you're going to use the AC method to factor, because there's a lot of steps involved. So if you just factor them separately and then combine them. So for the top here, I've got x squared plus 4x minus 5. So I know that I have to have an x times an x. I know I have to have two numbers that multiply to -5 and add to 4. Because I'm multiplying to a negative but adding to a positive, I know I have to have opposite signs because that's the only way to multiply to a negative. And I know the largest number has to be positive because the inside part is positive. The 4x is positive. So there's only two numbers that multiply to 5, 1 and 5. And if I do -1 times 5, that gets me -5. -1 plus 5 gives me 4. So that's going to be x minus 1, x plus 5. Or you could do x plus 5, x minus 1, either one. Now, I'm going to factor the bottom. This one is another one where I would basically do guessing and checking, sort of mentally in my head. And I'm looking for two numbers that multiply to 15 and add to 8. Because I'm multiplying to a positive, adding to a positive, they're all going to be positive. So to multiply to 15, I've got 1 times 15, which adds to 16, or 3 times 5, which adds to 8. So that means I have x plus 3, x plus 5. So if you need help organizing, do the top and the bottom factoring separately and show all the steps that you need to do, and then bring it together back into the rational expression. So I take my top, which is x minus 1, x plus 5, over the bottom, which is x plus 3, x plus 5. Now, if you're wondering why I didn't do the domain, like I started with the first one, it's because you can't really figure out the domain until you're factored. So the top, it was easy enough to figure out the domain because 5 minus x, it's easy to figure out what number makes that 0. But if you're looking at x squared plus 8x plus 15, figuring out what number makes that 0 is a lot harder to do mentally. And so you want to factor. And so now on my to figure out the domain, I look at my denominator of x plus 3 and x plus 5. So this is going to give me two numbers that I am not allowed to have be equal to 0, or two parts that can't be 0, because there's two different parts in the denominator. So the x plus 3 can't be equal to 0, and the x plus 5 can't be equal to 0. So for x plus 3, -3 plus 3 is 0, so that means x cannot equal -3. And then for x plus 5, -5 plus 5 is 0, so that means x cannot equal to -5. So for the original expression, we've got two numbers we're not allowed to have, or they make the denominator 0. So now that I've got that, now I'm going to start canceling. I'm going to see what cancels. And I can cancel out an x plus 5. So I have it on the top and on the bottom. So this would leave me with x minus 1 over x plus 3. Now, -3 is still not allowed because I have x plus 3. That is still there, so I don't have to write that part of the domain again because it's still in my expression when I ended. But I removed the x plus 5. So the domain part that matched up with the x plus 5, which disappeared, I have to write that part because that has disappeared. You wouldn't know from the simplified version that originally you were not allowed to have -5. So because I divided that out, and I have to make sure what I divided it out was not 0, I have to make sure I specify that. And so because the x plus 3 is still there, I didn't have to write that one, but I did have to write the part that got divided out.